So for the biz jet, we have these routes. And we talked about, well, this is obviously oscillatory because it's got part. This is barely damped, and this is highly damped. And so the names for these are Dutch roll, and it's the only oscillatory mode. So that's how you identify it. It's only one that has the imaginary part. And it's usually fairly well damped, so it's damped, but not highly damped, because if you look at the middle part, it's still pretty small. And often airplanes, in order to meet the FAR specs, will have to add an artificial damping to the Dutch roll mode. It's called a yaw damper, and it uses the rudder to try to counteract some of the Dutch roll motion. The Dutch roll motion is a yawing, rolling, banking, side-slipping motion. It's highly coupled. So it's the airplane flying along, and it gets a disturbance, say a gust from the side, and it will start to yaw, and it will bank and roll and kind of go through the sky like that. It's pretty uncomfortable if it's bad enough. So that's called the Dutch roll mode. This is called the spiral mode. And it's identified by a light damping, or it may actually be undamped. And this is a very slow, and that's why it's okay to be undamped or even unstable. It's a very slow banking divergence from straight flight. So it doesn't happen very fast, so an autopilot or a pilot can easily respond and keep it on track. And then this is called the roll mode. And this is the bank angle resistance. And it's highly damped because the big wings sticking out prevent much roll rate, much rolling motion. So you'll always get highly damped as long as you have wings. I want to watch the time because I want to give you a quiz back, so we'll stop in like 3 minutes. One more set of routes. If you look at a jet fighter, you see these routes. So it has the traditional modes. This is the Dutch roll. It's oscillatory, but notice it's unstable. So this airplane has to have a yaw damper output feedback controller added to it to make it stable in Dutch roll. Spiral mode is stable. And it's okay, it meets specs. Again, it's a slow divergence or convergence to drifting of heading. And then the roll mode is stable. So that looks good. So on some, again, the same deal, the aerodynamics took precedence over the aircraft design. And so they fix up the unstable Dutch roll mode with active feedback control. I'll post this on Blackboard. There's a handout that shows from another textbook that has some pictures and diagrams. So let me show you that real quick so that you can grab it from Blackboard. I rotated it and it vanished. So this is stuff I already showed you. This, look at it sideways. This is the spiral mode. This is a convergent spiral, so you get a heading shift and it comes back, or it could be slowly changing in heading. And it does slowly bank away. Oh, yeah. Sorry, thanks. There we go, I appreciate it. And then there's a page here that you can walk through this yourself. It talks about the Dutch roll mode. It starts out as a side slip, but then the airplane banks and rolls and yaws. So it's this weird motion of the airplane that's porpoising kind of back and forth through the sky. And if you want to experience this yourself, you can approximate it by going on the Highland Fling at Six Flags in St. Louis or the Zulu in Worlds of Fun in Kansas City. And this is a Ferris wheel type thing. Hey, have you guys seen this? Right, it starts out flat, spinning like this, and then it goes up like this, and you spin up. And well, when it starts coming back down, the cars kind of go back and forth like this as it goes. And that's kind of like the Dutch roll mode that you experience in an airplane. If we had an infinite amount of money and resources, we'd all do a field trip up to Worlds of Fun for this class. That'd be great, wouldn't it? And so let's stop there so that I can give you your quiz back. And we'll talk about how instead of solving the full big set of equations to get these modes, we can do some approximations that are easier to calculate.